Now it's time for Mars. Let's do a quick list of its vital statistics. Semi-major axis is now larger than 1 because Mars is further away from the Sun than dear old Earth. It's 1.52 times further away. AUs. Okay. The orbital period is 1.9 Earth years. So it takes almost 2 years for Mars to make one trip around the Sun. Next one is interesting. Its rotational period is 1.0 Earth days. To be more particular, to be more precise, it is let's see, where'd it go? 24 hours and 40 minutes. Slightly less than that, but you get the idea. So the Earth, the Mars day is very close to the Earth day. Okay, it's known as a SOL, S-O-L. We call them the people who work on with the Mars rovers. They have to work according to Mars days. Okay, because the rovers don't work at night; they only work during the day on Mars. So people who work on Mars rovers have to work according to Martian sols, S-O-L-S, sols, and not Earth days. So they have to work, basically they have to live with a 24-hour, 40-minute day, which means their days cycle in and out of phase. Their working days cycle in and out of phase with our days, which is really weird. They go to work, basically imagine going to work 40 minutes later every day for a couple of years. Okay. Weird, but true. But the rotation period of Mars is very close to that of Earth, which makes it kind of appealing from a living there point of view. The mass of Mars is quite a bit smaller than that of Earth, which means its gravity is far less. Okay, the gravity on Mars is you're going to be weighing a whole lot less on Mars. The radius is about half that of the Earth, 0.53 radius of Earth. Oh, this is 0.11 mass of the Earth. Okay, so it's about half the diameter is about half that of Earth. You could put 2 Marses across Earth's base, basically. Number of moons. Now we start getting something that's non-zero. 2. There are 2 moons. Phobos and Deimos. Phobos means fear, of course. Deimos means terror. So the 2 moons of Mars, of course the god of war, are fear and terror. And they're actually interesting. They're probably both captured asteroids. Okay, I'll read up about them in the last section of the chapter 10. But anyway, Phobos and Deimos are the 2 moons. They're small. They're not nearly as big as our moon. They're small, almost certainly captured asteroids. Density of Mars is less than that of Mercury or Earth or Venus, which tells you that the composition is something slightly different, but still not remarkably low. The obliquity of Mars's orbit is 25.2 degrees, which means it's not only does it have about the same rotation rate as the Earth, about once every 24 hours, it also has a tilt similar to that of Earth, which means you get seasons on Mars. Okay? You get seasons like you do on Earth. On Mars, those seasons are somewhat complicated, though, by other factors that don't really play in for Earth very much. We'll talk about those in a few minutes. The magnetic field of Mars is exactly equal to that of Venus, which is 0, my favorite number. Goose egg. No magnetic field. The eccentricity, this is interesting. For Mars, 0.09 something, 3. Now, that's actually a really big eccentricity. That means that the closest distance to Mars and the furthest distance from the furthest distance between Mars and the Sun is a lot further than the closest distance between Mars and the Sun. So the seasons on Mars are complicated by the fact that there's also this eccentricity. During certain seasons on Mars, it's going to be very close to the Sun and be very hot because of that. The Earth's differences in distance are not enough to make a big difference to our weather, but on Mars, with such a large eccentricity, roughly 4 times that of Earth's, it is enough to make a difference to their weather, to their seasonal weather. And finally, the surface temperature of Mars is 210 kelvins, which sounds nice and toasty. Until you convert it to Fahrenheit, it's negative 82 degrees Fahrenheit. That's average. It gets colder in some places, it gets hotter in some places, but that's the average. Compare that to 60 degrees Fahrenheit here on Earth. It's a huge difference. And remember, I told you that CO2 in the Earth's atmosphere has a lot to do with that difference. Okay, basically, we'd be living on Mars if it weren't for the CO2 in Earth's atmosphere. So it's really nice that we have that CO2. So those are the vital stats. Couple comments to make about the. Let me just see. Get this right here. The red color of Mars, and it actually is red. You can go out at night. Mars gets pretty bright. Not as nearly as bright as Venus, or as bright as Jupiter, because Mars is closer, but it's also quite a bit smaller than Jupiter and not as reflective overall. But Mars is red. Okay, you can go out and look at Mars and say, yeah, that's red. Now, how you do this is, turns out, if you want to see the colors of stars or planets, you don't just go look straight at the planet. What you do is you look at the thing you're trying to figure out the color of, and then look to other stars or planets near it, and then bounce back and forth. So you could go up and look at a really cool star like Betelgeuse, which is deep, deep, deep red, and you wouldn't really notice that it's red until you looked at all the stars around it and then compared them. It's in comparison that you can really, really, really see the color. Now, when Mars is super close, in opposition, we'll talk about that in a second, then the red color, you don't really need to do any comparing. But usually when you look at Mars, to really get a sense of the red color, you sort of have to bounce around, comparing it to other bodies up there to see that. Let's see. I want to draw a picture here of Mars's orbit. So here's the sun. There's our old friendly sun. And let's see, here's the Earth's orbit. Unlike the orbits of, there's the Earth, unlike the orbits of Venus and Mercury, the orbit of Mars encircles that of the Earth. So it's like this. So Mars's orbit is out here. Okay. And Mars can make that trip. Now, Mars and Jupiter, let me write this down here. Mars, Jupiter, and Saturn, Uranus, and Neptune are all known as superior planets. Not because they're better than the other planets, but because their orbits are larger than the Earth's and encircle the Earth's orbit completely. And Mercury and Venus are known as inferior planets. So we have 2 separations of planets, right? We have the inner solar system and the outer solar system, right? 4 planets in the inner solar system, Mercury, Venus, Earth, Mars. 4 planets in the outer solar system, Jupiter, Saturn, Uranus, Neptune. But then we have a different category, the inferior and superior planets. There are only 2 inferior planets, Mercury and Venus. Their orbits lie within the Earth. Then you have 5 superior planets. Their orbits lie outside the Earth. Okay. So if we look at the orbit of Mars, when Mars is over here on a line connecting Earth and Sun, okay, that's known as conjunction. Not inferior, not superior, just plain old conjunction. So when Mars is lined up with the Sun in the same direction as the Sun, it's always behind the Sun from our point of view. That's known as conjunction. When Mars is opposite the Sun, over here, that's known as opposition. And we've seen these terms already in our labs. Okay. With opposition, the elongation is equal to 180 degrees, right? Because the Sun is in that. If you're on the Earth, the sun's in that direction. Mars is in that direction. It's 180 degrees. So that's an elongation of 180 degrees. Remember, elongation is the angle between the sun and X. In this case, X is Mars. So at opposition, the elongation of Mars is 180 degrees. Then we have two other points here. Mars is here. This is known as, let me see, that's going to be eastern quadrature. Okay. In that case, the elongation is 90 degrees, right? Because on Earth, the sun is that way. And Mars is that way. It's a 90-degree angle. So if we go out and we point to the sun, and you point to Mars at quadrature, that's a 90-degree angle. And then down here, we have western quadrature, when the elongation is also 90 degrees. Okay, and these, in the same way that Mercury and Venus, in the last lecture we talked about the positions of Venus's orbit. We talked about inferior conjunction, superior conjunction, and greatest eastern and western elongation. Those points on the orbit correspond not only to Venus, but to Mercury. That is the inferior planets. They have those four. Superior conjunction, inferior conjunction, and greatest eastern and western elongation. Those apply to the inferior planets, Venus and Mars. Venus and Mercury. These 4 points, opposition, conjunction, eastern and western quadrature, are all points on the orbits of not just Mars, but all the superior planets. All of them. Okay. So that's a little bit of what's I'm looking for, vocabulary for you. All right. And again, you've already seen these in your labs, but I wanted to bring them up again here. All right. Anything else to say about Mars? Let me check and see. No, not for now. We will close this out, and next lecture we're going to talk about the large-scale topography of Mars. That means basically if you looked at a map of the geology of Mars, what are the main features you would see? That's up next.